Okay, so have you ever really, truly looked at a salt shaker? What if I told you that the stuff you sprinkle on your food is actually made from an explosive metal and a poisonous gas? I know, it sounds completely nuts, but it's not magic, it's chemistry. Let's break down how this is even possible.
So first up, let's meet sodium. This is a soft, silvery metal, but don't let that fool you. It is so unbelievably reactive that it has to be stored in oil just to keep it from freaking out and reacting with the air. It can literally explode if it touches water. Yeah, definitely not something you want anywhere near your dinner.
And then there's its partner in crime, chlorine. This is a pretty nasty yellow-green gas, and it is straight up toxic. In fact, it's so good at killing living things that we use it in swimming pools to wipe out germs. So, again, definitely not something you want to consume.
All right, so you take one super dangerous metal, you add one poisonous gas, and you combine them chemically. What kind of wild, catastrophic substance do you think that makes?
You get this. Simple, stable, totally safe table salt, also known as sodium chloride, the very thing you eat pretty much every day. Now, the fact that two incredibly dangerous things can create something so harmless, that's the core mystery we're going to solve right now.
To really understand the secret of salt, we have to start with the absolute basics. And the most basic question of all is, what is everything in the universe actually made of?
The simple answer is matter. Your desk, your drink, your own body, even the air that you're breathing right now. If it has mass and it takes up space, it's matter. It's as simple as that.
And all of that matter is built from a set of basic ingredients we call elements. An element is a pure substance that just can't be broken down into anything simpler by chemical means. It is the most fundamental kind of stuff there is.
You know, a really great way to think about elements is to imagine them as the universe's Lego pieces. They are the fundamental little bricks that you use to build everything else, from gigantic stars to a simple sandwich. And the complete collection of all of these Lego pieces is organized into what we call the periodic table. Each element gets its own little box and its own unique symbol, like Na for sodium and Cl for chlorine. Now, I know it looks complex, but honestly, you can understand a massive amount of chemistry just by getting to know, say, the first 20 or so elements on that chart.
So, we have our individual Lego pieces, our elements. Now, what happens when they start clicking together in a really special way? When at least two different elements join together through a chemical reaction, they form something completely new called a compound. The critical point here is that they are chemically combined. They formed a whole new unified team. And here it is. This is the key idea that solves our salt mystery. When a compound is formed, it becomes a brand new substance with its very own unique properties. And those properties are often completely different from the elements that made it. If we look back at our salt story, this is exactly what happens. You've got dangerous sodium and poisonous chlorine, and they undergo a chemical reaction. They bond together to form the compound sodium chloride, and in that process, they lose their old dangerous properties and gain the new, safe properties of salt. It's a total transformation. This brings us to a really important distinction in science, and it's something that trips people up all the time: the difference between a compound and a mixture. Understanding this is absolutely key.
A mixture is much simpler. It's pretty much just what it sounds like. It's two or more substances that are in the same place at the same time, but they haven't chemically bonded. Think about a salad. The lettuce and tomatoes are mixed, sure, but the lettuce is still lettuce and the tomato is still a tomato.
A perfect example is mixing sand with some little iron filings. You can stir them together, but you haven't created anything new at all. The iron is still magnetic and the sand is still sand. And because they aren't chemically joined, you can easily separate them. You just use a physical method, like grabbing a magnet to pull that iron right back out.
So let's just break it down side by side. The crucial difference is this. In a compound, elements are chemically joined to create totally new properties, and you need another chemical reaction to break them apart. But in a mixture, substances are just physically jumbled together, they keep their original properties, and you can usually separate them with simple physical methods.
All right, we have covered a lot of ground here. Let's just take a second to put all these pieces together and see how they fit into the big picture. It's a pretty simple hierarchy when you look at it. All the stuff around us is matter. That matter is built from basic elements, and those elements can either be chemically joined to form compounds or just physically thrown together to make mixtures. That's pretty much it. And that brings us right back to our salt shaker. After everything we've covered, I have one final question for you. Is table salt an element, a compound, or a mixture? And more importantly, can you explain why? Once you can answer that, you've officially understood one of the most fundamental ideas in all of science.